During the 20th century, companies and institutions have grown from simple one-location operations to complex regional, national, and international organizations. The effect of this growth has been an exponential increase in the amount of information these organizations must handle. And too often, reporting systems vary, and information is late or inaccurate. Management recognized the need long ago for a mechanized means of processing all this information. They wanted an ideal mechanized system that would pick up information right at the source of activity with perfect accuracy, process it instantly, and then deliver the precise result desired, exactly where it was needed, when it was needed, in whatever form it was needed. Now, man wasn't able to build this ideal system immediately when he first saw he needed it. It had to evolve. In 1890, Dr. Herman Hollerith developed the method of storing information on punched cards. By the turn of the century, early key punch machines enabled clerks to transfer numerical information from original documents to punched cards which a machine could read. Other cards were stored in tub files until the information on them was needed for updating or processing. Then all the cards would be sorted mechanically in this old vertical sorter. The resulting total is on this early tabulator and written down by the machine operator. Though this equipment was fast and accurate in its time, it was very limited in function. No subtraction, multiplication, division, or alphabetic characters. So the users were anxious for an improved data processing technology. Thus, new technologies were developed during the first half of this century to provide faster, more flexible accounting and record-keeping machines which were capable of performing information handling services for business. These machines, of course, were not computers. They were just fast, high-volume adding machines. In large organizations, these punched card systems required many machines, many operators, millions of punched cards, plus large amounts of floor space. Again, large users began asking for a new technology to process large volumes of transactions and to organize and present facts in a form they could use to better manage the business. Enter the computer and a new age. The Mark I, our first computer, was unveiled at Harvard University. It took another 10 years of development before the first production computer was installed at Monsanto in 1955. The first generation of computers that were installed from 1955 to 1960 were originally designed to do scientific and engineering jobs. Characteristically, they had slow information input and output performance, but their computing power was the marvel of the 1950s. Organizations with large volumes of commercial applications quickly adapted the scientific computers to do payrolls, invoices, and production control work. Once again, the users developed a need for a new technology. Why couldn't we have computers with fast information input and output for commercial applications? Fortunately, there were several major technological breakthroughs in the late 1950s. Transistors and printed circuits were developed, with their vastly improved speed and reliability over vacuum tubes and wires. A new automated process for manufacturing magnetic core memory devices made it possible for low-cost computer systems to efficiently sort thousands of records. Card input units, tape drives, and printers now could offer for the first time the speed and versatility needed by large commercial users. The combination of these advances brought about a second generation of computers in 1960 with the delivery of the 1401 system. This second computer generation, with its vast improvements in processing speed and capacity, made extensive use of tape input-output systems, especially for record-keeping jobs. Year-to-date records on tape could be read into or out of computers at the previously unheard-of rate of 41,000 characters per second. Besides speed of access, tape could store an enormous amount of information for its size, in comparison with punched cards. A standard reel holds 2,400 feet of 1/2 inch wide tape and can contain data equivalent to about 400,000 fully punched cards, or 200 card boxes filled with punched cards. This single reel of customer billing records includes account numbers, names and addresses, previous and present readings, rate, accounts receivable amounts, including arrears, separated by gas and electricity, and the net and gross bill totals. The second generation made another breakthrough. For the first time, a user had families of computers to grow within, which greatly reduced the problem of reprogramming when a larger computer was necessary. We had the 1400 family for commercial applications. The 7000 family was mainly used by the scientific community. And a new 7740 computer family was developed to do message switching applications. Now, what did all this advancing technology mean to a user of manual or punched card equipment in the early 1960s when he faced the decision of converting to the new tape-based computer systems? First of all, it meant a tremendous saving in space. A typical card system user had key punches, verifiers, collators, sorters, reproducing punches, accumulating reproducers, interpreters, accounting machines, and a calculator with attached punch and storage units. Upon the introduction of the 1401 tape system, much of this equipment was no longer required. The former card system carried with it 46 drawers of advance cards, 23 drawers of accounts receivable, and 32 drawers of name and address cards, which the 1401 replaced with less than 1 rack of magnetic tape. The reduction of procedural steps is equally dramatic. Customer billing on the old card-based equipment involved 21 separate machine passes to produce the customer bill, the new advance card, and revenue analysis. The 1401 system did the same jobs in just 7 machine steps. But in spite of these tremendous increases in computer efficiency, the ideal mechanized system still had not arrived. However, the early 60s brought a whole new revolution in technology. It resulted from a breakthrough into the world of the super small, the world of solid logic technology. Microelectronic circuits, more compact, making possible faster logical decisions than ever before, the product of years of progress. From electric relays, we advanced to vacuum tubes. Then computer circuits were transistorized. But as the speed of components increased, the distance electricity had to travel between them became a critical factor. So, we cut the distance. A new technology with virtually no significant distance between components. Microelectronics, in which 50,000 transistors overflow a thimble. These half-inch squares are called substrates. Circuit patterns are being printed on them. The basic elements of solid logic technology, chips and substrates, meet to form a circuit. As many as 6 of the active elements are placed precisely on a single circuit. The module receives one protective coat and then another. Solid logic technology, a new direction in data processing. Faster, smaller, and more reliable, this new technology made it possible to meet the user's crucial needs. And in 1965, the first of these third-generation computers with solid logic technology were delivered to the users. One computer family for commercial, scientific, and communications applications. A modular design that would enable the customer to have a system with the speed, storage capacity, and input-output units custom-suited to his precise needs. the flexibility of being able to add on or remove peripheral units readily as his needs change. Compatibility between second-generation programs and third-generation technology. Training of the user's professional staff on one system, rather than several families of computers. And, most important, better cost performance. Here we see a System 360 central processing unit, surrounded by its input-output devices, the card readers, magnetic tape drives, disk drives, and remote terminals. Also, there are control units and buffers that manage the data flow between the input-output devices and the central processing unit. One of the key developments in handling data storage was the magnetic disk device with direct access to each unit of data. What is direct access? Well, to get to an item of information that is in the middle of a roll of tape, it is necessary to read through the entire length of tape up to that spot. However, with the disk, any item, regardless of its position, can be instantly reached by the read-write head as it slips back and forth over the spinning disk. This random, rather than sequential, access feature of the disk is a great time saver for many jobs. On the surface of the disk, data is stored as magnetized spots. As in tape, the surface can be erased and used repetitively. These devices generally come in disk packs, each capable of recording several million information characters. By using many banks of disk drives, the storage capacity is multiplied to billions of characters. The unique qualities of these direct access information storage devices enable computers to move into entirely new application areas that weren't feasible before. And how has all this affected the user's mode of operation? Before, when punched card systems were used, a set of equipment was often located in each department. The payroll department had one set of machines, and the accounts payable department would have another set of machines. Then, when the first computers were installed, the transactions were sent to a computer room in batches to be processed. The payroll may have been processed from 2 p.m. to 2:45 p.m. The printed reports, punched cards, and checks would be returned to the payroll department. Then accounts payable would be processed for 2 hours, starting at 3 p.m. This method of operating was called batch processing. But now the method of operating is clearly indicated by the accelerating trend toward online, real-time information systems. Online terminals are devices through which a person communicates directly with a computer, either to give it information or to ask for and receive the results of a transaction. Real-time means that computing results come back within seconds, so they can be used to guide an ongoing process. It means computing while it happens, rather than after it happens. Sophisticated real-time information systems were originally developed for expensive transactions, but they're already being used for $10 to $15 transactions by motels. What do online, real-time information systems mean to customers and revenues? Let's look at a before and after example of an actual installation.
Good morning. At Houston Lighting and Power Company, a customer would call to question her last bill. The switchboard operator would put the call through to a customer service representative.
Just a moment, I'll ring the service representative to help you.
Mrs. Eccles? Yes, Mrs. Hinckley. I'll be glad to check it for you.
The customer service representative would take all pertinent information, name, address, and account number if available.
20591. Just a moment, please.
Then she would put the customer on hold and place a call to the customer reference area, where a reference clerk would review the billing referred to by the customer and supply the information needed to answer the telephone inquiry.
2750. 3420.
542, 429. Multiplier is 10 and service center is KY and no payments.
Thank you. Thank you for waiting, Mrs. Hinckley. In checking your account, I can
Total time to complete this transaction, 7 minutes, plus a great deal of searching out and paperwork. That was how it used to be at Houston Lighting and Power. But today, with the introduction of the computerized customer information system, all that has changed. The need for switchboard screening of calls is eliminated. Inquiries go directly to any one of the many telephone service representatives who can instantly select needed information on IBM 2260 display stations. A standard request, HB, history of billing. Now, however, answered with the aid of a computer system. The initial entry instructs the computer to search out and display record information, any one of which may be selected, displayed, modified, and restored instantly.
Count, Mrs. Hinckley. I see that this month's bill is considerably higher.
Not only speed, but verified accuracy ensure customer satisfaction no matter what the problem.
This period of time your bill covers. Yes, ma'am, and thank you for calling.
Probably the most dramatic of all the changes brought about by the introduction of the new customer information system is in the handling of what used to be a frequent and time-consuming operation. A simple request for a cut-in of service. Again, in the past, the call would come in first to the main switchboard.
Good morning, Houston Lighting and Power Company. Just a moment, and I'll ring the service representative to help you.
Mrs. Young, may I help you?
The service representative in a different department would take down the information needed to make a normal connect order and put the customer on hold while she checked the records.
Wait just a moment. Thank you. Mrs. Stewart, we'll take care of this for you Monday. Thank you for calling.
Total time so far, 5 minutes or more. And for HL&P, the operation of initiating a cut-in has just begun. The order would go through at least 5 departments. The entire procedure, from the original taking of the order to the final posting to the customer's record, would take from 5 to 8 days. But here's how the same new customer procedure is handled with the customer information system.
Good morning, Houston Lighting and Power. Yes.
At this point, the representative obtains information from the customer to enter into records.
What is the complete name in which you'd like this service carried? Bush. Robert J. Miss Bush, your service will be connected today. Thank you very much for calling.
And that's it. In less than 2 minutes, Mrs. Bush is assured of electric service the day she called for it. And because Mrs. Bush is a new resident of the Houston area, the system will also produce a Welcome to Houston letter. The computer now has all it needs to go to work. It validates the order, checking to see if sufficient and correct information has been given, as well as double-checking the history of any previous service the customer may have had with the company. The system then posts information to the customer's record, selects certain information from that record, and prints the order at the correct service center, where a field representative is given the order to cut service in for Mrs. Bush.
How fast is technology moving? In 1960, when the second-generation computers became available, we still traveled on propeller aircraft. But by the end of the 1960s, we are using online airline reservation systems as well as jet transportation. Computer technology has moved so fast that the main memory of computers, which started with speeds in terms of hundredths of a second, now work in billionths of a second. In fact, research people are talking about picoseconds, and a picosecond is to a second as 1 second is to 300 centuries. Computers have become so fast internally that they must be operated by special programs called operating systems, which enable the simultaneous processing of many jobs. We already know that the 1970s will bring the superjet age of technology, and we are fast approaching the ideal information handling system we dreamed of many years ago. We in the IBM company face the same challenge as you do, the development of real-time information systems on a corporate-wide basis for the 1970s that will enable us to plan for and control our business in the future.